So, the dodo bird, it's up here flying. You are down here. There's your pellet gun right there. Boom. You are aiming your pellet gun at the dodo bird. We know that the dodo bird is exactly 30 feet above the gun.
Wait,
You just do. Okay? You just do.
You carried a giant yardstick with you.
We also know that the dodo bird is flying at 20 feet per second towards you. Okay? So, as it flies, two sides of this triangle are changing. This side here, which I'm going to call Z, and this side here, which I will call X. Okay? Which one who can tell me? Who can tell me? Lauren, which one do we know the rate of change of? Z or X? Why? What's the rate of change of X? dx dt is negative 20. Negative 20 feet per second. Cool, because if the bird is flying horizontally this direction, X is shrinking at 20 feet per second. Cool? So, I'm asking you how fast the angle of elevation is changing. Okay? That's the angle in here. So we need some way to link theta to x, because I want d theta dt. That's what they're asking you. How fast is the angle of elevation changing? D theta dt is what? We know dx dt, we want d theta dt. We need an equation that links x to theta. What's that going to be? Tangent. Tangent will be 30 over x, or we could do cotangent like we did yesterday and make it x over 30. Okay? I'm going to do cotangent, just because I want x to be in the numerator for when I derive it. So cotan theta is equal to x over 30, and this is almost identical to the problem we did yesterday. We're going to derive this now. When you derive cotangent, you get negative cosecant squared theta times the derivative of the inside of that thing, which is d theta dt. Because I want x to be in the numerator, because it makes it easier to derive. It's going to simplify it down, okay? And when you drive the right-hand side, you get 1 over 30 dx over dt. So we want d theta dt. We know dx dt is negative 20, so I can plug that in. We're going to have 1. Come on now. We're going to have 1 over 30 times negative 20. D theta dt, we do not know. We need to know what cosecant is. And remember we said yesterday, cosecant is the reciprocal of sine. So it is the hypotenuse divided by the opposite side. Okay with that? That's from a right triangle. So if we come up to our right triangle, we have the opposite side is 30. What we need to know is what the distance from you to the bird is, and it says, man, it's 40. How nice is that? It just gives it to you. If it didn't give it to you, you have to find it some way. But that means that cosecant must be 40 over 30, which happens to be 4/3. Okay? And we're going to square it. So we want 16 over 9, and it's negative. Okay with that? To solve for d theta dt, we are then just going to multiply both sides by negative 9/16. Okay, so this right-hand side really simplifies down to 2/3, and I'm multiplying that by negative 9/16. And that is going to simplify down. The 3 and the 9 cancel, right? There lives a 3 up here, and the 16 and the 2 cancel, leaving an 8 down here. And the 2 negatives cancel, leaving a positive. So we have 3 over 8. And that's going to be in radians per second.
Why did you find opposite over